Alright everyone, just a little bit ago I posted some pictures of a really cool print that I did on my AnyCubic Photon stereolithography machine, and it got a really awesome response, so thank you guys for that. And quite a few of you asked me to do a video on the process that I used to achieve my result and get the holographic looking image within my 3D print. So I am going to do just that. I'm going to do start from finish. I'm not going to leave anything out. I'm going to do everything that I did exactly as I did it. And just keep in mind, this is a work in progress. I'm going to make this process even better and hopefully update you guys with that. So this is kind of how I did my first run. I'm going to include some things that I've discovered since then, but by and large it's going to be the same process. So here we go. I have a file prepared already, so I'm just going to walk you through what I did to make that, and it's actually already printed and it's sitting right here next to me, and you'll get to see it in just a little bit. But until then, I use SolidWorks. It's my favorite 3D modeling program. You can use whatever you want as long as it makes an STL file, but I'm going to make a part here. I just find that SolidWorks is the easiest to use in for the type of geometric models that I like to make, but it really doesn't matter. So the way to make text in SolidWorks is you have to make a line for it to follow, and then you make the text, you select the line, and you just enter what you want it to say. In this case I made it say my name, and I picked a font. I like Old English font because I'm a nerd. If I can find it, it's in here. And almost there. Here we are. I like this one. I usually select bold because it will make the letters bold, obviously. And what that does is that gives the spaces that are going to end up being your cavities that will show up as your quote-unquote holographic image be much bigger, and therefore easier to see and to drain. Now I'm going to make the text 1.5 centimeters, and because that's what I want to do. Alright, and so now that we've got the text, what we're going to do is extrude that, make it a solid, and 1 centimeter is going to work for me. So we go ahead and make that, and now I would like to point out while we're here that we're actually going to be printing the negative of this essentially. And so what you want to look out for typically are islands. And now an island is an area of the print that is unsupported by other material or support structures, and that will cause that area of your print to fail, or maybe a lot of your print to fail, depending on what is connected to that island and in what way. Since we're going to be surrounding this entire model with another model, we aren't going to run into too much of that because it's going to have resin on this side of it as well as the back side. However, where we run into trouble are where there's a lot of area that it has to make up all at once, bridging that gap. And so I didn't have any issues with the in-between areas of this S or the O or above the H here. But what I did have an issue with, as you'll see later when I show you the actual print file or the print that it made, this portion of the J had a little bit of an issue and it didn't form quite right. And as such, the cavity isn't as big as I would like, and it's not showing up or being empty enough to show up. And I think that's because of this flat area right here on top was just a little bit hard for that to bridge for whatever reason. You see, it has to bridge all this area. On the O, it has to go all the way across there, but it's much more gradual. So I think that's where it ran into some issues. Now in the future, what I might do is just hand draw this section and make it go up a little bit more or down a little bit more, or just be a more gradually sloping shape, and that way it will be much more easy for the material to bridge those gaps. But for now, that's what I've got. So what we're going to do is we're going to save this as an STL, and I've got it right here. I'm just going to do it again just because, to walk you through the entire thing. So I'm just going to save that. Alright, now we've got this. And so now, to make sure that I'm doing this in the right way, we're going to open up, oh, don't look at that yet. We're going to open up that file in Box. And you see, there it is. We're going to orient it the way we want it. Whoops. Oh, where'd my top go? What the hell? We'll try that again. Oh, that's why. That was weird. Anyway, so as you can see, we've got the model right now, and this is what we want to end up eventually being the negative space within our model. But we need to make that model and make sure that it encompasses this entire thing. So what I like to do is look inside the scaling tool here in Box, and it'll give you the actual dimensions of your model. And so it'll give you the dimensions of your model. And so now we can go back to SolidWorks, make a new part, and we can just draw a rectangle. And here in Box, we see that it is 62.5 millimeters long. And so we want our box to be just a little bit bigger than that. And so I'm going to make this 65 millimeters long. And now we can see that it is 25.5 millimeters tall. So we can just go ahead and make that 30. No, that's too much. 28. Whoopsie. Much better. And we know that I extruded the text to be 1 centimeter thick, and so we're going to make this just a little bit more than that. Go ahead and make it 15 millimeters this time. There we go. And now we have our box. And we can go ahead and save that as an STL. And this is my block right here. I'll just go ahead and make another one. And now we've got that. So the next step, get that out of there for now. The next step is to go to Mesh Mixer, which is a free program from Autodesk. It's pretty powerful for being free. It allows you to manipulate and join files pretty easily. And so I use it for this process. So what we're going to do is we're going to bring in this file. I don't know why it looks gross. Let's see if I can fix that real quick. I don't know if I can. That's okay. And so we're going to import the other file as well. Make sure you hit the append button so that it doesn't replace the file you've already imported. And here's our test block. And so what we want to do is we want to make sure what, I'm actually going to get rid of that and make sure. What you want to do is, I was having trouble with this before. What you need to make sure of is that the block that you want to subtract out is the second one in the object browser here. I was having trouble figuring out which order to do that in, and I was getting errors where the wrong model would be subtracted. But I think I solved it, so we're all going to find out at the same time. And so now we've got both of these models in here, and we need to make sure, use the transform tool in edit to move this around. We need to make sure that it is completely within this model. I just eyeball it and make sure it's centered. We actually want this part to hang out. That's going to serve as our drainage hole for that letter. And we can move this in a little bit. And so what you can do is click on this magnet, and you can see right through there, kind of an X-ray view. Make sure that it's centered. You can probably go a little bit to the right. Select it, edit, transform. You can use the arrows, or you can type it in up here. You can also use it to rotate and scale. That's all within this tool. And now we check it. Looks good to me. Make sure that magnet is unselected when we go ahead and do this. And now we control select both of these, and we're going to click Boolean difference. And that is going to hopefully subtract the text right out of that block. Now you see how that made the block look pretty gross. So what we want to do is take this target edge scale, and we want to slide it all the way down. And it's going to make us wait. And so, while we are waiting, oh, not even waiting that long. And so you can see how that cleaned up the edge quite a bit. It looks much better now. And so now we can go ahead and click accept. And it still did it wrong. Okay, I got that to work. So now, as you can see in our object browser, we only have one object, but you can see that it worked because where the text used to be, there is now a hole in the block. And so what we're going to do now is we're going to export this as an STL. I saved my earlier one as test cavity. Just make another one of those. And so now we don't need Mesh Mixer anymore, but we do need to go back into Chi2Box, open up that file that we just made, and there you have it. So what we can do is rotate to orient it the way we want it. And I'll get into why I orient it the way I do in just a second, but I do want that, you can tell that this is the bottom of the text because that's where the drainage hole in that H is. And so I want that to be on the bottom. And so you can tell that this file is in fact hollowed out. All of those letters are in there. And now what we're going to do is slice it. And so another trick that I like to use when I name my files, just to make things easy, I don't know if you can see it over here, but if I were to click save, I name my object, but then what I also do is I include how much material it's going to use and how long it's going to take, and that just helps me keep everything organized. And since I actually dye all of my resin myself, I don't buy colored resin, I only buy translucent clear and white. that allows me to accurately measure how much resin I actually want to use, and therefore I don't over pour or waste any resin, at least as little as possible, and know roughly how long I'm going to be waiting before I actually start my print. And even further on that, what I'll do is once it starts to print, I will set a timer on my phone for the time that it actually gives me on the printer, because I found that to be extremely precise, and go about it that way. And a note on the actual volume that it tells you here: while this volume is very accurate, I would recommend putting at least 25 milliliters of additional resin into your vat if you're going to print just one object and you want to cut it close, because while it will only actually use this much to make the object, you're going to want to make sure that the bottom of that vat is filled for the entire print, otherwise you might run out in the middle of the vat. I've had this happen many times, and while in the first many layers the print bed actually pushes down on the resin and spreads it out across the vat, it will not do that once the bed level is above the resin level and only the object is in the resin at that point. So make sure that you're adding, I like to do 30, but you might be able to get away with 20 to 25. I just like to be extra safe because I would rather use an extra 5 milliliters than lose an entire print. And that's just my 2 cents on that. But anyway, we're going to go ahead and save this .photon file, and now we're ready to go ahead and print it. But before we do print it, I just want to show you a tool that I like to use to make sure all of my prints are going to work out, and it's called the Photon File Validator. And I actually discovered this in someone else's video, whom I do not remember the name of, so I'm sorry to you, but good job. But what you do once you slice and save your .photon files, this will actually open those .photon files. And so right here I have that file. And what it will do is it will actually go through and analyze every single layer. Right here is what it's doing. And it will check for islands. And I mentioned before what islands are, and they're a big nuisance. And before I figured this tool out, what I would do is I would actually scroll through this right here one by one and just by hand look for islands, and it was really tedious and I would miss them frequently. But with this tool, fortunately this model, as I pointed out earlier, this model doesn't have any, although that's somewhat misleading. You can still run into errors, but overall if you're printing something like a minifigure or a different object, this is going to be really good at detecting those islands, and it will actually tell you right here all of the layers that have islands on them. Now it can go ahead and fix some of them for you, but the ones that it can't fix, you can still have that layer information. So you can come right back to Chi2Box, and actually what you can do is once you click on this and drag it a little bit, you can page through it with the arrow keys individually and get exactly to the layer that you want to, and then you are able to fix that island and add a support manually right here. So that's just a little aside about adding supports and using that tool. I found it to be very valuable. But now that we've gone ahead and checked it with this, we're going to go ahead and print. Okay, so the last thing we need to do before we send this thing over to the printer is cut our drainage holes. You can do that with the tool contained right here in Chi2Box, and we're going to want to put it back on its side for this, and you'll see why in a second. But basically, if you angle it right, you can kind of see the shapes right here that we're going to want to cut. Now before I used a 1mm hole, it actually might still be in here that way. Look at that, I used a 0.5 millimeter hole, and that was just too small. So I'm going to raise this to a 1.5 and just see how that works. I already have this set. This worked for this particular model. You're just going to have to play with this until that bore length is long enough to reach your cavity that's in here. So sometimes it takes a couple tries, but it will work when you have it set correctly. And so what you can do is use the slider here to see exactly where you're going to be poking through. And you can see here, let's just look at this for a second. See how this is connected with a very thin area. This is connected to this with a very thin area. These two halves are separated with thin areas as well, and this is a pretty thin area. We're probably going to want to drain all of those areas separately. And so what we're going to do is we're just going to leave it like this. We're going to hit add a hole, and we're going to see where we want it. I like to put it towards the bottom just so gravity helps us out a little bit. You can see where that green dot is, that's our hole. And so that looks like it's going to be a good size to not interfere with the model too much. Also, it's going to be on the back, remember, so that we are not going to see this at all. And so really we might even be able to make it a little bigger. Let's go up to 2 and just see. That'll probably make it easier for us to drain as long as it fits in these areas. So let's see, well, I want to put one right here in the big part of that little end there. Where was that? Right there. Kind of hard to do this sometimes. So I'm going to try and just angle it so we can see that shading like we did before. See, and there you have it. That's our first hole. That's going to be a nice sized drainage hole. Hopefully that will help us out a lot, because I think when you see later my actual part, you're going to see where some of the liquid is actually still in the cavities and it's not coming out very well because the holes I used were just too small. So I want you guys to be able to avoid that if you can. There's another one. And like I said, we're just going to do all of these cavities separately. Oh, see, I missed the area with that one, so it gave me an error, but maybe I might have to make this hole a little smaller. Let's see. Let's see if I can fit it in there. Might be tough. Looks like we'll be able to get it. Might take a couple tries, so let's go ahead and get that done. Alright, let's see. Nope. Oh, there we go. Okay. And so now we're going to do both halves of the O. Again, towards the bottom if you can help it, if it'll fit, just because gravity is going to help us. Just get them as close to the bottom as you can. I've found that it will drain slowly over time, even when you think it's not going to. Even through the little holes that I used before, it is still draining in my other model. And so that's a good sign, but we still just want to make these holes as big as you're willing to make them to make that easier. And so this half of the H is actually going to drain through the bottom just because that's the way this model worked out, but we're going to put another drainage hole in the other side. And so when I set these up, after I give them their alcohol bath and rinse them off, I let them lay. You can go ahead and sand it if you want, but for a while after I'm done with the whole process, I let them just lay on their back or however they're going to drain best, whatever orientation that may be, for a while, just because you're going to see the liquid coming out of these holes for quite some time as it just slowly drains out of there. And for me, it's probably slower because my holes are so small, so hopefully you guys are going to use some more appropriately sized drainage holes and it's going to work out a lot better for you. Alright everyone, welcome to my dojo. This is my sanctuary, my workshop, and my bedroom. And this is where I spend most of my free time when I'm not working on my car. Here is a lot of the crap that I've been making lately. Really awesome files that I found mostly on My Mini Factory. I've been painting this guy. Really excited about my mini factory. You should check it out. Here's my PC setup. Was going to use my GoPro to make this video, but it is dead. And there is my vintage Badger air compressor for my air gun to paint these bad boys. Big shelf of nerdy electronics crap. And my old dinosaur Flash Forge Creator Pro, dual extrusion capable, not currently set up. I do have it wired, but the motor's not in. Obviously, because I have two spools hanging up. And here's my SLA setup. Got two photons, 50% of them work. And here's some of my tools that I use. This is actually a strainer for your kitchen sink, but I really like this because it fits perfectly into the biggest of these funnels, and I don't need to hold it, unlike those paper funnels that come with the printer. You can use your other hand to stabilize whatever you're pouring, and it's much more effective, I think. I 3D printed stands for my funnels and my droppers. Love having droppers for various things, and you can see here all my little bottles that I use for mixing colors. My big guys are in the back. In this coronavirus crisis, drastically short on this stuff. Make sure you conserve it. I have about this much left in that bottle, and I am cherishing it like I would my girlfriend that I don't have. And so here you can see I've labeled my colors in the various bottles, and I label them according to what the actual dye that I use is called, just so I can keep it straight. Here are my dyes. I love these. Got them on Amazon. I think I posted the link somewhere on the forum or on Reddit, but these are awesome. Let's see if I can get that to focus. Yeah. I don't remember exactly what they're called, but I got them on Amazon. I think there's 18 different colors here, and I think the whole pack was around $15 or $16. Definitely worth it, considering I've dyed at least this many colors using them, and only ever bought white or clear, which I found to be the cheapest resin. So that's just something to keep in mind if you want to save your resin. I dye it out in batches according to what I want to print with it, rather than just pouring a whole mess of it into my vat at once and just pouring it back in. I find that you end up wasting a lot of it that way. Also found these really cool beakers on Amazon. They stack, so they don't take up a lot of space, and they have milliliter markings on the side, so they coincide really nicely with the measurements that you get from the software, and I can use those to measure out things really nicely. This is currently my alcohol bath, sadly. Waiting out on maybe an Easter present from the folks for that wash cure station from AnyCubic. Really hoping for one of those. If not, I'll probably just buy it because it looks awesome. But anyway, we're going to get to how I finish this print now. So I've already printed it. I had it done before I started making the video. Here it is. You can see that it comes out, and as you know that after you wash it in the alcohol, it comes out kind of opaque. Even if you use the clear resin, you can't really see through it that well, and that's because of all these layer lines. Even though they're small, they really add up. If you look at it in the light, though, you can really see how that's going to come out, and it looks great. So you can still see that there's actually quite a bit of liquid in those cavities. That will also come out. My famous print that's blowing up on the Facebook page and Reddit right now, right here, you can actually see how that bottom jaw is starting to develop, because I've been having it rest on that drainage hole, and you can actually see here it has been getting additional liquid out. So I think over time it is going to show up better and better, and it's looking really great. I'm really pleased with how that bottom mandible is showing up there, because before you really couldn't see it at all. So I'm hoping that this happens with this guy because I'm really stoked on this font. I think it looks really cool. The H looks great. I think what I'm finding is that I just need to use bigger drainage holes, because look at the size of that versus these teeny little holes that I use back here. And I thought they would work, and they're working all right. You can see that there's definitely liquid coming out of them, but it's just not, it's going to take a long time for them to drain. I think that something about this size is the way to go. Especially I put them all in the back. How often are you going to look at your name backwards? So I figured the back was a good place for them, or the bottom, but that was really the only place that the bottom lined up. So, and I didn't want to drill holes all the way from the bottom because you would definitely be able to see those from the front. So the bottom didn't work out for this particular model, but it will in the future, I'm sure. So I just used the back on this guy, but these holes should definitely be bigger. Just for your own reference, when you go ahead and do this, make the holes bigger than this so that they drain. And so what I do is much like finishing any piece of woodwork, or maybe even finishing a car when you paint it. You start, I have these very fine sandpapers. This is actually 1200. We're not going to start with that one. You start at the highest grit and you work your way down. Let me just find, here's my stack of them. Sorry for the poor lighting, by the way. My room is not lit very well. That's why I have that awesome halogen ring lamp that I use. That thing is a monster. Really great. Just real quick, my nerd desk here. It's dabbled in some jewelry making, as you can see. Got my cool gaming setup, my PS2 OG, and my really cool soldering iron and stand. Some music making stuff over here underneath robot schematics. Hopefully I'll do that one day. And some more music stuff. Anyway, I keep getting distracted because I am very lucky to own a lot of cool things. But anyway, what you're going to use is, I like to do wet sanding for this. It gives you a really nice shine on the edges. It's going to give you your finest detail. And so I have this dropper here, and I've just filled it with room temperature water all the way up, and you're just going to continually make sure that this has plenty of water on it while you're sanding the edges. So I'm going to get this camera set up so that I can show you that process. Alright, so now you've got the bird's eye view here of what I'm going to be doing. So I'm going to also turn this light on, maybe. That's a little better. So I've got my dropper here. I'm just going to put it right on the sandpaper. Don't worry about the sandpaper, it's cheap. And I'm just going to pick a side to start with. I'm going to start with the front. That seems like the best side to start with. Kind of lightly spread the water out, and you don't need to apply a lot of pressure. I'm sure many of you have done this before, but it's going to take a while. You just got to keep on going. You're going to see the water that you apply is going to start to get milky. That's a good thing. That's actually the bits of your print coming off and giving you a nice even surface. So I'm going to go ahead and get through the 600 grit here that I'm using on both the front and the back. Well, for this video, I'm only going to worry about the front and the back. The top is actually pretty nice already because it was the last layer, and the bottom came off of the print bed. So those are pretty clear as they are. And the sides, just don't really plan on looking through them that much. Yeah, I'm still feeling. You can see those layer lines right there. That's what we're trying to get rid of. So what I've just got is actually a slightly more coarse grit sandpaper. This is actually from Testers, which is one of my favorite modeling equipment companies. They make really nice paints and some other things. But these are films rather than sandpaper. They're actually kind of on a plastic backing, and so they can get wet a little bit nicer. And since we're staying flat, this is the perfect application for them. But I just want to expedite this process a little bit. Getting very close, very, very close. Okay, we've almost gotten rid of all of the layer lines, just a little bit more. And then we're going to climb right up the ladder of sandpaper grit until we get to 12 or 1500. All right, for my purposes, let's see if I can clear that off for you guys. I think that we have done a good job of getting rid of those layer lines. Look at that. Nice and smooth, huh? All right. So I'm gonna grab, just get a, I like to wipe off, just at least dab my sandpapers nice and warm. Get the water off of them just so it's not lingering too much. And now we can just climb right up the grits. So I just went from about a 350, this is 600, and now we don't have to go very long on these, because really we are just getting rid of those scratch marks progressively. $800. Look at that. 1000. We're gonna call it quits at 1200. That's nice and smooth. You can see already how much better you can see everything inside of it. And we are not done yet, not quite. All right, just gonna give it a little rinse. I like to use lukewarm water. Ignore how gross my sink is. All right, and what you're gonna notice is that, ooh, that's looking nice, looking nice. But you're still going to notice, actually, what you're going to see is that even though we've done all of that sanding, once this dries, we're still going to get some marks in the front. Now it's really super smooth, but we're going to get all sorts of scratch marks in the surface still. And let's see. Yep, see how it's looking opaque again, kind of like right when it comes out of the alcohol? Well, next I'm going to show you how to fix that. Alright guys, here we are in my garage. There's my other project. The wreck that is. New sides for it right there. Transmission for it over there. Luckily the engine is right there. Anyway, we are out here because, as you can see, despite all of that sanding we just did, you can see all of those scratch marks that are still in there. And so what we're gonna do is we're gonna fix it. This is actually a trick that I learned from reconditioning old plastic headlights on a crappy car. So you get the surface nice and smooth, and it is really smooth to the touch. And all of those cracks are never going to get filled in or taken away by sandpaper, no matter how fine of a grit you go. So we just got some basic clear coat. I use gloss. That's what you're going to want. Any brand doesn't really matter. And we're just gonna hit it with it a little bit. And already you can see the difference in the finish. Now look how clearly you can see that H. That's the baseline here, because you saw earlier we have the much bigger drainage hole in the H. The S also looks very good. You can actually see the liquid in the O still, and that's my fault for not making very good drainage. Same with this J. There should have been additional drainage in the J, and that top part we talked about earlier just didn't form very well. But the rest of this looks really good, guys. So as you can see, that is my process.